Things that probably aren't found in most homes and most libraries, and this is my library, filled with loads of my books and things like that. And one of my antiques here that I'm trying out to see if it fits, and I've got the prop up here, is a Model 200 Wincharger from the 1930s. And you can see on the tail there's still some Wincharger. And then down here, made in Sioux City. You can't really see the Iowa, but that's where it was. Then Model 200 tail boom. And then you got up here, this assembly really folds from the other side. There's a pulley, you can't quite see here, that would feed down and pull the tail vane out of alignment so that it's at, instead of facing into the wind, it faces with the wind so it doesn't rotate. You got your gear case here, and unlike the Jacobs, this uses a much smaller generator and instead steps it up. And that's really one of the cool things, right? This was sort of like the Chevy of windmills before rural electrification, and that's one of the things I really like about it. This is sort of approachable technology. That's one of the things I like to build into my own things, whether that's like the tortilla press or the grain mill, using as inspiration cool things that have been done in the past, not reinventing them. But this is sort of one of those ideas of simplicity and real adherence to simple things that work. One of the cool things here is the governor, and this is where the blade would be. I need to carve the blade, copy mill, carve it just as a stub blade. Again, the full 10-foot long one is there on top of the bookshelf. But here's how it governed itself. Instead of furling the blades, this is a fixed blade. So some had a function so they wouldn't overspeed, where it would tilt up. So it would go lean up in, as the wind went, it would tilt up. Wincharger had a couple different ways of doing it. Some others did and still do change the pitch of the blades. And that's fairly complex to some extent. The Wincharger, the smaller ones, and this is the largest of their models that use this method of controlling overspeed. It actually goes, and you can see probably here, as these get faster, it'll actually pull on this, and those become air brakes. So they fly out. In effect, what you've got is the wind still pushing against your prop and spinning it. So you're putting on the gas at the same time that your air brake is flipped out and is putting on the brakes. So, you know, it's not perfect. It's probably not as nice as those tilting pitch governing ones. But man, you know, really simple. You've got a spring here. You've got a connection so that both of your brakes fold out at the same rate. You've got your connecting rods. Really, a really elegant solution to the issue of how you control speed. That combined with, you know, the idea that you didn't have to have that direct drive generator, that you could have the step up the gearbox, stepping it up and using a much lighter, higher speed generator. Really a cool idea. You can see down here, this is where you've got your double slip rings, grease fitting, and their towers were renowned to be fairly simple too. And here right at the bottom, you know, an easy welding project. You're not going to find a stand for a 1930s Model 200 Wincharger in your local hardware store. So I just welded this up, and you can see I need to do a little bit of sweep up after I've just installed it. But just welded from a disc brake and some scrap steel, and then bolted to the frame. So just something that I thought I'd share. Really cool, really neat design, really a little bit of the ultimate in simplicity to get the job done. And it did the job and can still do the job wonderfully. Very durable design, very cool design. So for more on this, more in-depth photos, go to engineeringtechnologypress.com. The link is in the show notes below. Thanks.